Right, C34, June 2017. It's a functions question. G of x, call it G. 6x over 2x minus 3, and there's the domain. X is greater than 0. We're going to find the range, the inverse function, say its domain, and then G of x as a single fraction in its simplest form. Right. The range, first of all, because x is greater than 0, the whole thing's going to be greater than 0 because the top and the bottom are both going to be positive. So I know that the g of x is greater than 0, but I don't know how big it gets. I've got 6x on the top, 2x on the bottom. I can't really sort of see straight away. So maybe try some values. We put 0 in to start off with, we get 0. Put 10 in, we get 60 over 23, which is about 2.6 as a decimal. Put 100 in, get 2.955, 1,000, and we look at this. Oh, they're getting closer and closer to 3. If we put 10,000 in, very, very nearly 3. So it looks like the whole thing's just getting closer and closer to 3. Could it ever be equal to 3? Well, if I put the g of x equal to 3, multiply by this bottom line, and then if I take away 6x off both sides, I'll have 0 equals 9. So no. So it looks like g of x starts, it's not 0 because the x is greater than 0, but it starts above 0 and just gets closer and closer to 3, but doesn't quite make it. So notice the strict inequality signs there. Can't be 0, can't be 3. So it needs to be g of x is greater than 0, but less than 3. You could look at this and think, oh, I've got a fraction here, I've got 6x over 2x. But if you put something really big in, 3 becomes less significant. So the whole thing just gets closer and closer to 6x over 2x. Because as x gets bigger, the 3 becomes neither here nor there. Algebraically, I could divide the top and bottom by x and write it as 6 over 2 plus 3 over x. And as x gets bigger and bigger, this term gets closer and closer to 0. So the whole thing gets closer and closer to 6 over 2 or 3. You could even write it like this. That's 6x. I could write it as 3 lots of 2x. So if I write it as 3 lots of 2x plus 3 lots of the bottom line, take away 9, I can cancel these out. So I'll break it up into 2 fractions. I'll have 3 times 2x over 3 over 2x plus 3, which is just 3, and then minus 9 over 2x plus 3. And this term gets closer and closer to 0 because the bottom line just gets bigger and bigger as x gets nearer and nearer to infinity. G to the minus 1, standard procedure, write y equals g of x, and then we isolate the x's. So we multiply by this bottom line, multiply this bracket out, get the x terms on one side. So I'll take 2xy over here, take the x out as a factor, and divide. So the x then is 3y over the 6 minus 2y. And remember to write it as g to the minus 1 of x is 3x over 6 minus 2x. The domain is 0 to 3 because that's the range of the original function. The range of g was g of x was in between 0 and 3. The composite function gg, well, it's the g of g of x, which is g of 6x over 2x plus 3. So I'll put 6x over 2x plus 3 where x is in here. So it's 6 lots of g of x over 2 lots of g of x plus 3. Got to simplify it though. So I'll multiply the top and bottom by 2x plus 3, the bottom line of the fraction. So this will just become 6 lots of 6x. This will become 2 lots of 6x. And this term will be 3 lots of 2x plus 3. And if I multiply all these brackets out, I've got 36x, 18x, plus 9, because I've got 12x here, 6x here, and 9. And simplify it down and get 4x over 2x plus 1.